Hi, I'm from SAS Institute. We are an analytics company. And basically, we do a broad range of analytics, everything from specific point solutions like fraud and risk, marketing, all the way through general machine learning and text analytics and everything like that. So basically, I am here to speak to you about approachable analytics, and I'm here to show our newest interfaces that we're releasing this November, and how somebody like me, who is not necessarily a trained data scientist, can get access to their data and see what the insights are and move all along the analytical journey of preparation and model development to deployment without necessarily having to be a classically trained data scientist, rather like what we like to call a citizen data scientist. So there we go. So this platform that we're using for this approachable analytics is SAS Via, and what I like to say is it's a platform for everybody because it has visual interfaces, programming interfaces, REST APIs, and so I can be a super hardcore Python programmer or a super hardcore SAS programmer, but I can also be a business user like myself and access all of the same capabilities, the same data, and the same scalable in-memory engine from the same environment, regardless of which persona I am. So the moniker that I like to use about this interface that we're showing is simple, powerful, and automated. And we like to say SAS is trying to make the jobs of a data scientist like the day at a spa. So how are we simple? Like I said, we have this one environment where you can move seamlessly from your data preparation to your model deployment without having to change between different applications, different interfaces, all of that kind of stuff. It's collaborative. We have this idea of projects across all of the different personas. And of course, we have these APIs to all of the different programming languages like Python and R and everything like that. So it's powerful because the core of this engine is a distributed in-memory engine. So it can scale to 20 plus, hundreds of nodes, right? It can sit on top of your Hadoop cluster. And so it can really solve any sort of big data challenge. We have our structured and unstructured analytical capabilities, as well as all types of machine learning capabilities. And then finally, automated. So we have hyperparameter auto-tuning to really scale up the performance of models, and you can seamlessly deploy into a database environment and run and score your models against the things that you developed and everything like that. So a day at the spa with all of these capabilities. So without further ado, I will move into the software. All right. Okay, so as you can see, here's my landing page, and I can, choose where to start. I can start with preparing my data, or I can jump straight into building models off of something that already somebody else prepared. I can manage my models. We have the idea of workflows, and so, this would be in a highly governed situation where you need to check off your model development to meet certain criteria before it goes into production, things like that. But I'll just start with the basic flow, which is, okay, I want to start a project. I'm going to start preparing some data. So I have a plan for my data preparation, and I am working with loans data. So I am going to be predicting somebody defaulting on their loan based off of a variety of different characteristics. And so, I can get a sneak peek at my data, right? But I actually want to join this against my broader customer data set that has all of the geographic characteristics. because this has, it has birthday if I want to incorporate age, as well as my geographic characteristics if I want to do analysis on that. So, as simple as that, I can, quickly join my data, and then all of this happens in memory. So, if this is 50 gigs, right, it can be in 5 machines. If it's 100 gigs, it can be in 10 machines, and scaling out, so on and so forth. And I can do various other types of data transformations to prepare. But at this point, I'm going to move into the exploration phase. So let me actually save this target table. So joined loans. And here I'm saving my plan if I want to replay that plan against other input sources. And I can expose like a REST API and schedule it that way if I want. So let me joining loans. OK. All right. So I'm saving my target table. And I'm going to save it to this public library so that anybody else who wants to work on it has access to it as well. But let me go ahead and explore and visualize my data. All right, so this is our exploration interface. And so basically, I can just drag and drop and start to explore my data. This is going to be what I'm trying to predict. So I'm actually going to make that a categorical column. And so I have all of my geographical data. But let's say I'm trying to see the relationships between all of my numerical inputs, right? And so we have this auto-charting concept. And let me actually remove, there we go, OK. So I'm going to change this into a correlation matrix. There we go. All right, so I can start to see the correlations between my different inputs. I can also start to investigate, like, if I want to see if there's any skews in my data, like this is highly skewed, then maybe I want to edit that before I move into the modeling phase. And like I said, I'm like a citizen data scientist. I don't have necessarily classical training, so I'm able to just explore, and I have basic understanding of what is good practices, but this isn't necessarily the heavy-duty modeling interface. But I want to I want to standardize that column, so I'm just going to apply the natural log to it. All right. And so as you can see, there's like no coding involved, right? It's all just point and click. And so now I have maybe a more standardized column that I can use for analysis or something like that. But straight from this environment, we have all of our explorations, right? Different ways of slicing and dicing your data. But then also we have more advanced analytics that we can do. Forecasting, network analysis. And then we get into our more advanced modeling. So let's say I want to build a neural network. I can just start building a neural network. I'm going to choose my response, which is whether it's going to be a bad loan or not. And then I can choose my predictors. I don't want my IDs, OK. And it will just build the neural network on the fly for me. And then, I have the opportunity to see like an importance plot of the different variables or something like that. I can edit the neural network if I want to add a hidden layer or something like that. So this is all very intuitive for me as a citizen data scientist. But then if I want to go further and like automate my model building process, I can actually do what we call create a machine learning pipeline straight from this visual interface. So it's taking all of the actions that I did, my data preparation, my natural log, calculated column, all of that kind of stuff. It's putting it into a project, and then it's creating a machine learning pipeline that I can build on top of from here. So now, I have my interactive data preparation that I did. I have my neural network that I did. But I can put in other types of models if I want to, like a gradient boosting model. And then I can go in and I can tweak all of the different features for this model if I am an analytical expert like that. We also have the opportunity to do hyperparameter auto-tuning. So I'm choosing, we have this patented genetic algorithm that uses advanced optimization techniques to find the best values of the parameters for all of these different machine learning models to get the best lift. So that's the beginnings of the pipeline. But one of the things I love most about this environment is that we have these projects and templates. So it's baked with lots of different best practice templates. So I can have a basic template for my binary target that I can use that will come with a machine learning pipeline that's already built out with imputations of missing values, transformations. There are more advanced templates that I can choose from to start out with. And then I can save templates that I've created for others to use if I have the best version of the gradient boosting with the best parameters, right? I can save that for my colleagues to use. And so I'm going to go ahead and kick off these jobs. All right. And they will be running in parallel on our distributed environment so that afterward, then I can go and compare across the different pipelines that I've done. So if I have one pipeline dedicated to regression-based techniques, and I'm using all of the best methods for regression, and then I have another pipeline dedicated to neural networks, another one dedicated to tree-based techniques, right? And then I want to compare across all of these different ones, and I don't have a cluttered environment, I can do that across all of these different techniques. So while it's training, one thing that you can do is you can actually get the batch code for this so that you can retrain these pipelines in batch on a scheduled basis if you want to do that. All right, so these pipelines have finally finished. And so I can move into the comparison across these different pipelines. And it chooses my champion model. And then what I can do is I can register this model to a model manager environment that has versioning. It will have model decay plots if we're running on a regular basis or something like that, so that I can have all of these projects that I build in a more governed environment. But then, I have my fit statistics and everything that I could want from, this tournament that I created. But the last aspect of this environment is, okay, I want to be able to publish this to either a scoring API or publish it into a database. So I can publish the models into a Hadoop database if I want. So if my data is in if my data is in any of these databases, Hive, for example, I can connect to the Hive database, and then I can publish that model to run in Hive, for example. Or, I can download a scoring API that, it can be submitted in any language, right? Because it's just a REST API, but we build it out so that you can submit it from the SAS programming language or from Python too, if you want to do that as well. So that, I've moved in 10 minutes, right, from just wrangling my data, joining some tables together, and then exploring it in that environment, building a tournament with these pipelines, and publishing APIs, all with the click of a button. And that's what we mean when we're saying we're trying to make data science like a spa. So with that, I'll take any questions. Yeah. Oh, yeah. I'm sorry, I can't. The data size of this? So this one was running on just a single machine, so it was 10 gigs. Yeah. I'm sorry? How big was the memory for this machine? I think it was maybe 256 gigs or something like that. But we actually have this is like a group environment, right? So you can see like all of the different tables that have been loaded for basically my whole team of 50 people who's all using this. So, yeah. Any other questions? OK, thank you for your time. If you want to check up with me, I'm at the SAS booth.